Assalamualaikum and good day everyone. Okay, for this video I will show you about the lab practice of the CFD flow analysis using the mixing elbow model. Okay, so we are using the CFD Hyperwork 2020 for this CFD flow analysis simulation. Okay, I will show you step by step how you want to set up the model of the flow analysis using the mixing elbow, and then we should see the result of the flow analysis. Okay, first you open up the Hyperwork CFD 2020. Okay, and then you imported the geometry of the mixing elbow. Okay, you can click on the file, import geometry model, import CAD, and then you search the mixing elbow .x underscore t. Okay, x underscore t. You select this file. Okay, you open up, and then it will show you the geometry import option, the hierarchy as a part, split components as a body. So just leave it as a default. You just click on the import. Okay, so this is the mixing elbow. Okay, you see first the geometry. So we want to evaluate the flow when this is a inlet of the part. Okay, this is the first inlet, this is second inlet, the small inlet, and also the top one is a outlet. Okay, so the fluid will enter this mixing elbow from this first inlet and also the small inlet here, and then we'll go out to this outlet. Okay, so we will use the fluid, okay, as the flow analysis here. Okay, the first step, we want to validate the geometry first. You click on the geometry, you validate first. Okay, so the result is a surface check is a 0, the solid check is a 0, so means that the geometry is a good enough to run the CFD flow analysis. Okay, so you don't need to do repair for the geometry. Okay, next thing, we want to assign the material. Okay, we want to assign the material, and then you go to the flow. Okay, click on the material icon there, material assignment. Okay, you click on this, you click on the mixing elbow part, and then you choose the water. Okay, you choose the water, and then you click OK. So it will assign the fluid material to the mixing elbow here. Okay, and then next we want to define the inlet, okay, and also the outlet. Okay, first we want to assign the inlet first. You go to the profile icon here, you click on that, you click on the first inlet, the bigger inlet here. Okay, and then you set the average velocity is a 0.4. Okay, 0.4. You click OK, and then you set the small inlet here. Okay, you choose the surface area of the small inlet. Okay, and then the average velocity is quite high here because it's a small inlet here. You set it as 1.2. Okay, you click OK. Right, so in the setup browser there at the left side, it already have the first inlet, the bigger inlet, and also the small inlet, which is a second inlet. Okay, next we want to define the outlet. Okay, we want to define the outlet here. You click on the top surface area there. Okay, leave it as a default value for the static pressure and also pressure loss factor. Click OK. Okay, so we already defined the inlet. Okay, this is the inlet first, the first inlet, the second inlet, and also the outlet. Okay, so since the geometry is a half, okay, geometry is a half, so in actual we have the solid geometry here, so we need to define the symmetry, because if you don't define the symmetry, it cannot flow because it's not the full solid modeling. Okay, so you apply the symmetry here, you select on the surface here. Okay, this surface has a symmetry plane. Okay, precedence is 1, you just click 1. So basically the CFD analysis we run in the complete set. It's not the half here, but for the overall. okay, overall mixing elbow. It's not the half. This is a just section cut. Okay, we already apply the symmetry, and then we already define the inlet outlet. We already define the material, and then we need to mesh the model. Okay, you click on the mesh type. You go to the batch measure. Okay, batch measure. The average element size is 0.025. Okay, 0.025 is quite small. Okay, the curvature is 0.1. The mesh growth rate is a 1.3. Okay, for advanced, you can choose thin layer meshing. Okay, numbers if you need to make it at the critical area layers. Okay, you can define as a 8. Okay, and then you just click the other one. Okay, the other parameter you just put as a default, and then you click on the mesh, so it will mesh it the geometry. Okay, so like this. Okay, so you already defined. So this critical area, okay, you can, if you see the meshing type here, okay, the critical area, which is the small inlet, we have a very small element, okay, compared to the other side, which is the bigger inlet and also the outlet. Because this critical area, we need to refine the mesh, because if you put the bigger size, it's not capture the flow analysis there. Okay, after you already meshing it, okay, so this is a solid. You can go to the section cut here to see the what is inside this model. Okay, so this is a solid mesh. Okay, okay, and this critical area is quite small of the elements. Okay, compared to this is quite bigger element size compared to this small inlet area. Okay, alright, if you're already meshing it, you can run for the flow analysis. Okay, for the flow analysis, so you run it. Okay, the name type, you can name it. Okay, parallel processor, you can choose if you depend on your laptop or CPU, the number of processor. You can untick the define preference, and then you click on the run. So you can wait. Okay, after you finish it, you can right click, and then you can see the result in the acute field view. You right click, and then you choose visualize in the acute field view. Okay, okay, so this is the result. Okay, okay, first one, you want to see the pressure. Okay, okay, you can untick the show mesh. Okay, so you can, it don't appear the meshing element here. It just only show you the okay, the result of the pressure. Okay, alright, the scalar one is a pressure. I want to see the pressure first, and then you can see the legend, show the legend. Okay, so the result of the pressure is about 385. Okay, so this is a pressure. The higher pressure is at the small inlet compared to the first inlet, the bigger size, and also the outlet. So the outlet flow pressure is quite low compared to the inlet. Okay, compared to the inlet, especially in the small inlet. Okay, and then next I want to see the velocity. Okay, velocity, you can go to the tab of the surface here. Okay, you can create, so it will create the surface ID2 here. Okay, and then I want to choose the scalar as a velocity magnitude. Okay, calculate, and then I can choose the symmetry output. Okay. Okay. Go back to the surface ID one, which is the pressure one. You just untick the visibility. Okay, untick the visibility. So this is the result for the velocity. Okay, the result for the velocity. You can display the legend here. Show the legend. Okay, so this is the velocity magnitude. So you can see the velocity plot here is quite high, which is 1.99 at the small inlet. Okay, at the small inlet. So the contour plot red here. Okay, it show that this is a higher velocity flow at the small inlet compared to the bigger inlet and also the outlet. Okay, and then you can show the velocity magnitude here. Okay, you create another one. Okay, you create another one, which is a surface ID 3. You can go to the geometric. Okay, display type, you choose the vectors. Okay, option, click on the option. Head scaling, you can choose the 0.5. Length scale is a 0.2, 2, and the skip is a 37. Okay, you can close. Okay, the scalar one is the velocity magnitude. You just choose the OSF, click OK. Okay, you can see the velocity magnitude here. You can see the geometry. Okay, if you zoom in, you can see the arrow here. Okay, see the arrow. It's quite high velocity magnitude here. Flow in the small inlet and also the small outlet, and it will go to the outlet here and there. So this is a velocity plot. Okay, velocity magnitude, the plot here. Okay, so this is how you evaluate the result of the velocity, the value of the velocity magnitude, and also the pressure here. So you can choose any of the result here to see the flow here. Alright, so that's all for the flow analysis of the mixing elbow. Hopefully you can try it. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.